lecture we'll see whether the given number through a basic decimal number or the input basic decimal number is divisible by 2. That is nothing but whether the given decimal number is even. We are interested to find a even number or a given decimal number. So as the problem says that the input is basic decimal number, so our input set for a designing of DFA is nothing but a number that is from 0, 1, 2 up to 9. Okay, basic decimal number. Then states, okay, these states are nothing but we are interested to find out whether given number is even number. So I'll take one state that is having a remainder 0 and I'll take another state that is having a remainder something. So Q1 is having a remainder something and Q0 is nothing but having a remainder 0. Means Q0 is nothing but our initial state as well as a final state. Okay, so Q0 is our initial state as well as a final state. Okay, so we'll design a state transition table for this particular problem. So our states are nothing but Q0 and Q1. Q0 is one of the state and Q1 is one of the state. So Q0 is nothing but even number and Q1 is nothing but a odd number. So our input will be divided into a certain sets. Okay, that is 0 is totally divisible by 2, 2 is totally divisible, 4 is divisible, 8 is divisible, okay, and a 6 is divisible. Okay, so these are even numbers. And next is 1, 3, 5, 7 and 9. Okay, these are the non-divisible numbers. Okay, so I'll take this Q0, I'll provide input out of this particular set. So Q0 0, it is giving a decimal number 0, 0 divided by 2, it is giving a remainder 0. So I'm getting a state that is nothing but a Q0. Similarly, if 0 2, it is having a decimal number 2, 2 divided by 2, it is giving me a remainder 0, 0 4, it is giving me a decimal number 4, 4 divided by 2, it is giving me a 0. Similarly, Q0 will be having this particular input set. So 0 1, it is giving me a 1, so remainder is nothing but 1. If I'll take 0 3, remainder is nothing but 1. If I'll take a 0 5, remainder will be 1. Okay, so means if we'll divide this particular set with the 2, we are getting some remainder. Okay, so I'm having a state that is nothing but Q1. The next, the Q1 is with this 0 2 4 8 and 6. So 1 0 is a decimal number I'm getting as I'm providing this input set to Q1. 1 attached to 0, it is giving me a 10. 10 divided by 2, it is giving me a remainder 0. So for remainder 0, I have a state that is nothing but Q0. So Q0 is for remainder 0 and this is Q1 is for remainder 1. So I'm getting here Q0. Then Q1 with 1, 1, it is providing me 11. 11 divided by 2, it is giving some remainder. So for that I am having a state Q1. Okay, so this is a state transition table for designing a DFA which accept a even number. Okay, so for this I have to write a state transition equations. So state transition equations will be having a state associated with certain input. Okay, now I am having an input set 0 2 4 8 and 6. Okay, it is giving me a output state that is nothing but Q0. Similarly for Q0 with input 1 3 5 7 9, it is giving me a output state that is nothing but Q1. Similarly for Q1 with input state 0 2 4 6 8, it is giving me a output state that is nothing but Q0. Similarly Q1 with input set 13579, it is giving me output that is nothing but Q1. So these are all the equations of transition. Now I have to draw a state transition table. So for that I require all the states. So now here I am having two states. One is nothing but a Q0. Q0 is initial state as well as a Q0 is final state. So I'll double circle it, and another state I am having that is nothing but a Q1. So Q0 with input 0, 2, 4, 8 and 6 is going to Q0 itself. Q0 with 1 is going to 13579. Q1 with input 0, 2, 4, 8, 6 is going to Q0, and Q1 with input 13579 is going to Q1 itself. Okay, so this is a total state transition diagram for designing a DFA to accept a even number over input basic decimal number. Okay, so in the next lecture we'll see regarding to designing a DFA to accept a binary decimal binary number divisible by 4.